When we assign types to columns, we're restricting what sorts of values can later be put into them. If we say that a column is an integer, we shouldn't be able to put the word pies in it. That's important because if we later want to take the sum or something, we can't add the string pies to some numbers. But that's not the only sort of restriction we might want to put onto a column. Imagine that we're building a database for a retail store. In one table, we have a list of all the products that we have for sale. In another, we have all the sales that we've made. Whenever we sell something, we insert a new row into the sales table. By the way, the name SKU or SKU on these columns is just a name for stock keeping unit, which is an ID number or code that's commonly used for products in stores and warehouses and so forth. We expect that every SKU in the sales table will refer to one over in the products table. But what if we inserted a row in the sales table that didn't match any row in the products table? It wouldn't make any sense. We don't have a product number 23. Inserting this row must be a mistake. And it's a mistake that the database can catch, but only if we tell it to. When we create a table, we can tell the database that a particular column should only have values that refer to the key of another table. To do this, we use the references keyword. Create table sales, SKU text references products. If the name of the column is the same in both tables, then we can just use the name of the table over here. Otherwise, we would use the name of the table followed by the column in parentheses. In this case, this is actually unnecessary, so we don't need to use it. So a references constraint is a little bit like type checking. It catches bugs that might lead to our database not making sense anymore. In database terminology, we'd say that references constraints help us maintain referential integrity, which is our assurance that values in a column over here will always refer to values in a column over here.